What's up, guys? So today we're going to be doing a continuity style question that involves a piecewise function with three separate terms. So we've got x squared when x is less than 3, 9 when x is equal to 3, and then x plus 5 when x is greater than 3. So it looks like we're switching from function to function right when x is equal to 3. All right, so the first part of the question asks whether f of x actually exists at the point x equals 3. Now that part's pretty straightforward. Basically, all you're looking for is whether there's a real y value solution to our function when x is equal to that point. And from our piecewise, we can clearly see that when x is equal to 3, f of x is equal to 9. And that means that there is a real y value solution associated with x equals 3, and it's 9. So yes, the function does exist there. Now, a lot of times you'll actually have to plug that in. So for example, if instead of 9, we had x squared, then we'd be plugging 3 into x squared and seeing what real y value solution we get there. But yeah, so for us, the function does exist. At x equals 3. All right, now for the second part, we want to discuss whether the function is continuous at that point, including the type of any discontinuity. So basically, I think it's just asking, is the function continuous, and to kind of name any discontinuities that may have occurred. All right, so to see first if the function is continuous, what we're doing is we're checking that all these y value solutions here to x squared, 9, and x plus 5 are identical at the x value where it's kind of switching from one function to another. So in this case, that's just checking to see that if I plugged in 3 into all of these 3 kind of sub-functions, am I going to get the same y value solution? Well, for the first one, if I plug in 3 into x squared, I'm going to get 3 squared, which equals 9. If I plug in 3 into the next function, well, I mean, it's just 9. Can't really even plug 3 into that, so that's just also going to be 9. Into the last function, where x plus 5, I'm going to get 3 plus 5, and that equals 8. So basically my solutions, for the first one I get 9, for the second one I get 9, and for the last one I get 8. Now that implies that there is actually a discontinuity here. And that's because basically what's happening is when x is less than or equal to 3, our function seems to be going up to 9, but then when it's greater than 3, it's switching to x plus 5, which starts at 8. And so the function is going to look something like this. In this gap between our filled in point and my open point is what's called a jump discontinuity, because essentially the function is jumping from kind of one line to another line. All right, so this means that f of x is discontinuous when x equals 3, and there is a jump discontinuity.